Hi, this is a series of lectures dealing with Chapter 2, Descriptive Analytics. We're going to be talking about descriptive analytics for possibly a couple weeks, but the more important aspect about data is going to be dealing with the nature of data, how we model it, and also how we visualize it. Let's start with what is data. According to our textbook, data is a collection of facts, and it's obtained from experiences. Yeah. It could be numbers, words, so on. What's really important here about data is understanding that data is more than just a symbol. Like, oh, I've got an X. Well, what does that equal? Well, I could say, well, that is equal to the number 2. Well, that's great. X equals 2. Wonderful. Is that data? To what? Is this students? Is this dogs? Is this the number of laps a person has run around the building? I don't know. So data is actually has some meaning. So we have to be careful when we talk about data. Is that what does it mean? Like, what is the meaning of data, right? So keep in mind that with that data, it has to be representative of something. It can't just be simply a number or a word or an image. We have to be able to assign it some kind of meaning in order for it to create information and create some knowledge. So data is source for information and knowledge, but without that meaning, it will never work. So with that, it's important that we make sure that our data is always clean. It's always of the highest quality because it is critical for our analysis. Now, data in organizations comes from a variety of different areas. So the first thing, of course, you've probably heard of things like SAP, Oracle, or other types of ERP systems, right? Well, data comes from these areas as well, and these are just basic business processes. We now know with social media, there's a huge amount of data that comes from this domain, with people liking stuff, with people commenting. We know that there's text data, images that post, and so on and so forth. So that social media space is now a new source of data that people have been looking at more and more over time. And another thing is this whole idea of Internet of Things, right? So, like, what is the Internet of Things? Well, keep it one good example that more people are very familiar with is a lot of people have Fitbits or Apple Watches or something, and it's always recording something, right? So it could be recording your heart rate, number of steps you've taken, whatnot. These are things that are assigned to you. They have some meaning, but they create data simply by existing, right? Temperature weather stations are also that kind of thing. So with all these types of data sources, we're always looking at how do we combine all of it and store it. So we have to assign it some kind of meaning to store it so that way we can perform our analytics, so that way some decision maker out here on the far end can be like, wow, that is an interesting analysis, right? So data allows us to apply different types of analytics, and that gives us some kind of knowledge and information so that way we can make our decisions. So what is data that is ready for analysis? So we're going to use a variety of different types of terms. So I strongly recommend that you get familiar with what these terms are. So let's talk about a few of these. We're not going to talk about all of them in great detail, but let's talk about reliability. And then we'll talk about reliability versus accuracy. So reliability pretty much is implying that when we get data, it's not corrupt, right? So if we're collecting data from a social media source or from a business process or whatnot, that there's not going to be any kind of changes to that data after it's stored. So a lot of times when people talk about data, they always say, oh, well, it's been filtered or it's been manipulated or whatnot. So data reliability is really important, right? And we need to make sure that when it's recorded, that it's recorded consistently time over time over time. And the opposite of reliability would be like, let's say I'm going to go measure the temperature of the day. Well, if it was a reliable temperature reading, I might measure at 8 a.m. every morning, right? At least it's consistent, it's appropriate, and I'm going to store it into some kind of spreadsheet, and that spreadsheet has read-only access across the public. Now, with recording that data, it's pretty reliable because it was taken at 8 a.m. every morning, et cetera, et cetera. Now, let's talk about how is this also accurate data? You could argue that that data is also accurate because it was taken consistently, correctly, at the same time every day. But let's say that we really need an analysis of the day where it's at the hottest time. So 8 a.m. during the day may not be the most accurate measure of the hottest day or the time of day where a temperature reading is taken. So this is where that data may be reliable for what it is, but it may not be accurate for the kind of analysis that we're going to be doing. And so on. We're going to talk about, security and data privacy, accessibility makes sense. Data richness. If you're going to be doing a temperature measurement, you might also do pressure and humidity. Maybe also a couple of other things. Was it raining? The level of precipitation and so on. So all these aspects about analytics kind of affect, or data collection and data itself kind of affect our analytics. And it's important to understand our data as we go through our analysis problems. All right. So we'll talk about data on different levels. We're going to talk about structured data, data that's been pretty much organized so that way computers can process it, and then unstructured data that's really kind of intended for people to process. And then there's semi-structured with like HTML, which might be a combination of all the things. It's important to know the taxonomy of data, right? So we started talking about structured data. So structured data is very common, what we know, right? There's we can very easily explain numerical data, which is data that can be measured at intervals, which would be like, okay, the difference of temperature at 8 a.m. versus noon is so many degrees, that's an interval. And no matter what you do, when you subtract 1 degree from the other, you're always going to get an interval. However, you can't do that and figure out a ratio, right? Usually ratios are dealing with percentages. Now what we might be able to do is take that difference, that interval, and then evaluate the percent change from one to the other, but that always is dependent upon the change in that interval. Now also we have nominal and ordinal data. So the most important thing to know about these two, nominal data are things like, I don't know, names like John, Mary, Susan, right? They have some meaning because they represent people, but the difference between that and ordinal data is that ordinal data matters based on the order that they're in. So January, February, March, April. So if we're going to be evaluating categories, let's say male, female, this could be nominal, but there's not one that requires to be first or second, where order, like days of the week, months of the year, those always require some order. I'm going to pause there and we'll continue this lecture in the next video.